Figure 18-44 shows the requirements for a disconnecting means and controller that are used to disconnect and control motors rated 2 horsepower to 100 horsepower. Now notice the overcurrent device in the panel board. We're using a circuit breaker or fuses. It would make no difference. But again, we would use table 430.52, and in your column 2 and 5, for fuses or circuit breakers, we use 150%. Now again, remember the table is a 4-step procedure. What type of motor do you have? What is the phases of the motor? What is the code letter of the motor? And then select your devices. In this case, it's fuses or circuit breakers. It's 150% is what we would find. Now, the switch is rated in horsepower. It's a horsepower rated switch. Sometimes the switch will even have overload protection with it. In this case, if it's just a switch, then naturally the controller would have overload protection, see? Now, the motor is 2 horsepower to 100 horsepower, as shown, drives a generator with overload protection, see? Now, the disconnect, what we're looking at here, has to be capable of interrupting the lock rotor current of the motor, as well as the running current. Provided with no voltage release would be provided with running overload protection, not exceeding 125% of the motor's full load current, which would be 430.6A2 says use the nameplate that is listed on the motor. Now, for more information on the controller, look at the NEC loop. Review 430.81, 430.82, and 430.83, as well as 430.84. Now, that's what we recommend for the designer to use as a loop to kind of do a case study concerning the controller. Now, the disconnecting means is always in 430.109, but in this case, it's an Autotransformer-Type controlled motors. So it's 430.109D as in dog that we would use to perform our design work. So that's what this figure 18-44 is illustrating.